The Lord is with you, math analysis students. I thought I'd just put maybe a few of these questions on a video, which will be helpful to you. May God guide us and shine a light before us through His Son Christ for these purposes. I did do this one in class number 11. I want to do it again, just in case someone is not sure of it. It says here, solve 1 over r is equal to 1 over r1 plus 1 over r2 for r1. So we want to have an answer of r1 is equal to. So the thing to do is to get the r1 term by itself. That's actually r2. I want to get the r1 term by itself. So how do we do this? Well, this is what we can do is subtract 1 over r2 from the right side. But if we do it on the right, the principle of justice says we have to do it also from the left. So we subtract 1 over r2 from the left as well. So what are we left with? 1 over r2 will cancel. And on the left side, we'll have 1 over r minus 1 over r2. On the right, we'll have 1 over r1, which is almost what we want to get. We could ever flip this right side, and we'd have r1 over 1, which is the same as r1, and that will be equal to. Problem over here is that we don't have a fraction, a common fraction. We've got two terms joined together by a negative. So what we want to do is, let's take it up here so we have some space. 1 over r minus 1 over r2 equals 1 over r1. So we can find the least common denominator of r and r2, which is just like 2 and 3. If we had 2 and 3, then the LCD would be 2 times 3, or 6. So the least common denominator is going to be r times r2. That's kind of like the 2 times 3 I mentioned. Here, r times r2. Now, what goes here? Multiply this by r2. That means we have to multiply the numerator also by r2. r2 times 1 will give us r2. Similarly, to find what goes here in the numerator, we multiply the r2 by r, which means we have to multiply the numerator here by r as well. So r times 1 would be r. The right side remains the same, just waiting for the left side to be a common or normal type of fraction. So here we've got it now. Common denominator is r2, so we can write r2 minus r1 all over r2. That's equal to 1 over r1. Now we can flip the right side fraction and the left side fraction, and we get r2 over r2 minus r is equal to r1 over 1, which means r1. So that would be our solution, because when we're solving for r1, we want to say r1 is equal to. All right? Okay. Is there any around here? I trust that these will be fine for you. Let's go to the other side. Still looking for ones that I think might be potentially troublesome for people. Just the quadratic formula is fine. Completing the squares. Let's look for this one which takes substitution. Oh, here it is, number 19. There might have been some questions on that one. What we want to do here, we want this to look like a quadratic. So the objective here is for it to look like ax squared plus bx plus c equals 0. This is what we want it to look like. It doesn't look like it right now. I showed you one method of doing it. This might be maybe an easier method, I'm not sure. But what we want is we want this first variable to look like a square. And the second variable to be, let's say, x to the 1. We got x to the 1 here, this to be x to the 2. So if we do this, if we say let u, let me try this, let u be equal to square root of x, since this is the square root of x, and I want to find x, then I've got to square this side to find x. So if I square, let me just take it down here. If I square the right side, you know that the square root of x squared is going to be x. If I square the right side, I'm going to have to square the left side as well. So this means that u squared is equal to x. Now substituting, let's substitute all in terms of u. Substituting. Here's what I'm going to get. I'm going to get 2x, and instead of x, I'm going to write u squared minus 7 times the square root of x. 7 square root of x is u. That's the initial setup we have here. I'm going to put u minus 30 equals 0. Okay? That's one way we could do it. And then we could do the factoring. We're going to have a 2u times u. That will give us a u squared. We want to have a 7 in here. So we want to have a negative 30 here. So I'm thinking 6 with 5. And since it's a negative 30, then one has to be positive, one has to be negative. Okay, I'm going to make the bigger one negative, smaller one positive, because when I do negative 6 times positive 2u, I'm going to get negative 12u, and 5 times u would give us 5u, and negative 12u plus 5u will give us a negative 7u. So from this we can get our solution. Two options here. Either this has to be 0, 2u plus 5 has to be 0. The other option, u minus 6 equals 0. From this, when we subtract 5 from both sides, we get 2u equals negative 5. Similar to what we had before. Dividing both sides by 2, we get u equals negative 5 over 2. For the other option, we add 6 to both sides, we get u equals 6. But what is u again? U is equal to the square root of x. So I can write the square root of x here. Instead of u, square root of x equals negative 5 over 2. Okay. And squaring both sides in order to get the x. Square this side, square that side as well. We get x is equal to 25 over 4. For this option, u is equal to 6. So for u, again, I'm going to write the square root of x equals 6. And to get x, I'm going to have to square the left side. But if I square the left side, you know what I'm going to have to do for the right side. I'm going to have to square the right side as well. So x is equal to 36. So these would be our two answers. X equals negative 20, not negative, but positive 25 over 4. X equals 36. And we could go back and check those. All right. God bless you now, and I trust that will help.